going to talk about data-driven DevOps. And for some reason on the website you can see the subtitle of my talk, which probably makes it even more interesting because you have no idea what are we talking about. This. So before we even start, the most important slide of this talk. I prepared a special landing page for you. JFrog.com is the show notes. All the slides are already there. The video I'm recording here, hopefully I tapped all the right buttons and plugged in all the right cables. So you will have the recording sometime tomorrow. All the links, everything that I'm going to mention is already there as well. And also a place for a comment and rate and a little raffle. Amazon Echo Dot for thank you for being here. If you go there, you can participate, and you're not a lot of people, so probably win as well. Just to make sure, this URL is, where is my, oh, here you go. This URL is in the bottom of every screen. So if you forget it, it's all there. Okay, so we'll start with a very sad story. A story about a cobbler and his children who have no shoes. And to make it fun and a little bit interactive, let's start with a poll. So the way this poll works is that you just raise your hand. So how many of you are software engineers or used to be software engineers or write some code? Everybody. Perfect. All right. How many of you are optimists? 80%. Yep. Which is pretty accurate, because I would claim that this craft is so frustrating that without being optimist, you can't really survive. Nothing works almost all the time, and you kind of hope it will work, and that's optimism. So yeah, you have to be an optimist to be a software engineer. Another question, how many of you are self-confident to some extent? Imposter syndrome is live and everything, but still you know what you are doing? Again, about 70-80%, which again makes sense, right? We are professionals. We had some education in this field. This is why they pay us money. We assume that more or less we know what we are doing most of the time. So let me generalize and say that the majority of software engineers are optimists and think they know that we are doing. And this is great, except those two are cognitive biases. Optimism is actually Dunning-Kruger effect, in which we think that we are better than other people. And I don't know how many of you saw the latest Stack Overflow annual report. They had this question about rate yourself as a software engineer. Are you kind of a below average, above the average, or above an average? Well, 80% of the people are somehow above the average, or they think they are. Again, which is fine. We understand why, because otherwise they will be clinically depressed all the time. We don't want that. But we think that we are better than we are, and that's okay. Self-confidence is also a problem. One of the greatest books in computer science is The Mythical Man Month. If you didn't read it, you have to. And the link is, by now you know, JFrog.com/show notes. So read it. And one of the things there is the second system syndrome. Second system syndrome is you did something big and complicated and you did it right. And now you have the self-confidence to go to the next thing, in which you will probably try to do the same thing, but since this second system is not like the first one, your second one will be a disaster. You will learn from there, you will understand that the different things should be tackled differently, and probably the third one will be better. But second is horrible, and this is because you have self-confidence. So the consequences of those two is this. That's a Venn diagram. Now, when you think about it just a little bit, I bet you will agree with me on this. The better you know how some software works, the less you like it. It's a little bit like sausages, right? You don't go to a factory if you like sausages. But what can you do? We work in this factory, and even, you know, the software from the company I work with, JFrog, which I obviously very invested and think that our software does a great job. There are tons of stuff that I look at and I'm like, oh, who wrote it, right? So that's okay, that's fine. Those are the consequences. The other one is this. Every software is 80% ready 80% of the time, said every developer ever, right? Because this is what we truly believe. It's not a lie. This is what we truly believe. I did some home improvement project on weekends with a buddy of mine that we also deliver a lot of talks together, Leonid, and I swear to God, we were 2 hours to completion most of the 2 days weekend. Seriously, we knew exactly what we were doing. We assessed it. It was 2 hours. And 2 days weekend. Well, eventually it was 2 hours, and eventually we got it done Sunday night. Started Saturday morning. 2 hours of project. Sunk costs is something else that we kind of take very deeply. If we are invested in something, and we know that we know what we are doing, and we're almost there, giving up is extremely hard. Because we're almost there, right? Why would we give up and start 2 hours to completion? And the biggest, this is all fine. This is why we are human. This is how we work. In the end of the day, as I mentioned, this is why we actually survive in this industry. If we are realists and we gave up when we should, then probably nothing would ever be done because everything is constantly horrible. We ignore it, and this is how we continue. The only problem with that is that we share those inputs here. What's that? It's a stand-up meeting that we have every day, hopefully, the majority of us, and we share those delusions with our peers and managers as facts. Yes, 80% done. Yes, I'm going to be done in 2 hours. Yes, that's a fact. And then we go with those facts to the rest of our organization. This is how departments in our organization measure. Sales, easy peasy. They have Salesforce or whatever, they have numbers. We sold this and that. This is the number of dollars in the bottom line, easy. Marketing, well, not that easy, but still, here's the number of leads. Here is, I don't know, net promoter score. People like us, people don't like us, people heard about our brand, people didn't heard about our brand. I'm going to measure for marketing in a couple of slides. You will see, we have numbers in marketing. Support, we have numbers in support. Number of tickets, time to resolution, escalations, SLA, how do you call it again? Analysis of if people are positive or negative, all this stuff. Yes, this. Finance, never heard about what, I have no idea what they are doing, but apparently they have numbers as well, and that's again money, that should be pretty easy. They have some tools, okay, whatever. HR, they have some tools, they have some numbers. You know, this is how many resumes we got, this is the funnel, this is the churn, this is the happiness of work, of working force, everything is calculated. And then we have engineering. 80% done. 2 hours to completion. Those are our numbers. And obviously, when others collaborate and speak about the numbers and even fight about the numbers, this is number of leads. No, that's not enough leads. No, you don't sell. We give you good leads, we give you bad leads. It's about numbers and facts. It's like a good fight. And then there is engineering. 80% done. We're almost there. The release was 2 months ago, but it's only 2 days to completion now. Yeah. So we hate it. You hate it. Let's talk about how we change it.
Well, what if we take emotion out of the process and base it on empirical metrics, then we aren't really making the decision. The data is.
So we can hurt our friends' feelings without taking any responsibility? Me likey.
Yeah, so me likey as well. I hope you likey. We can insult the rest of the departments in our organization without taking any responsibility. And with that, welcome to this talk. My name is Baruch Sadogursky. I'm Chief Sticker Officer at JFrog. That's my real business card, by the way. I have them here. I can show you. Also, Head of Developer Relations. I'm at Baruch, at JBaruch on Twitter. By now, I hopefully convince you to follow me. If not, my Twitter handle is also on every slide, so you have the opportunity later. Very convenient. I think about you. And so if I didn't insult anyone in the opening of this slide, this is probably going to change during the entire talk. So I apologize in advance. This is who I am, and it's hard for me to be on the other sides of the spectrum. So I apologize if I insult anyone during this talk or later in the Q&A, which is a proper time and place to insult people. Well, yeah. It's not that we didn't have metrics before in engineering, before DevOps. Obviously, every engineering silo had their own metrics. So in dev, we had stuff to velocity, we're going to talk about it, architectural complexity and technical depth. This is how we measure technical depth. Compliance, number of, I don't know, like licenses and security vulnerabilities and all. Ops, they have their own SLA, they have their own metrics like SLA, probably one of the most important ones. Cost of environment setup, average customer cost, tool stability, all those were before. And QA, they had their incident rate, their defects, mean time to recovery, code coverage, etc. Right? All those were created before, but now in DevOps, we're going to merge everything together. And the color that you see here is a color of merging everything together. I'm very sorry. That's Photoshop. And then you go like, okay, what is this magic metric that we have now that measure DevOps? We already had aggregated metrics before. So for example, velocity. Velocity in Agile is this holy grail of metrics. Right, and if you want to know if your Agile is successful, you ask about how's your velocity. And we want the same magical metric in DevOps. How's your DevOps? Oh, my DevOps is fine, thank you very much. It's 42 something. 42 what? $42. In the end of the day, most of us work for for-profit organizations. Those of us who work for non-profit organization or maybe government, which is like anti-profit organization. Did I manage to insult anyone? Not yet? Okay, it's coming. You still have some metrics which eventually translate to money. It can be like efficiency that you measure with money. It can be your spending. It can be other people's taxes spending. I'm on the roll. But eventually, it's all about money. And this is cool because if we are talking about DevOps as we unify everything, eventually we're all there for one reason only, and that's the bottom line of the company we work with. And it has this similarity to every like big metric. So like velocity. They're very easily understandable. Velocity as well. If we produce more quality code in a period of time, we're good. If not, not so good. And it also creates the unity because everybody understands very easily what we work and what we are doing. If you take now a software engineer that writes code and speak with him about SLA or mean time to recovery, they're not really connected. When we speak with them about, you want to get salary next month, you better do it right, then it actually makes more sense. Okay, so we have this unified metric, and now let's see how good it is. Let's do the exercise with velocity. And this poll is a little bit different. When you vote, you keep your hand up until it's not more relevant to you. So who knows what velocity is? Hands up, everybody, perfect, hold them up. Who knows about what burn down chart is? Everybody know, that makes sense. How about who has a burn down chart? Okay, we lost like third. Okay, who looks at their burn down chart? We lost more people, and we're now about on half. Who trusts their burn down chart? Okay, almost no one. There is one more, so someone can still hold it. We'll hold it. But okay, you got the point. The problem is, even if you don't, what do you know? What do you do if it doesn't look right? That's the biggest question. And the problem with this metric of velocity of burn down chart going right direction or wrong direction is that it's not really actionable. You can look at it, you can see, okay, it's going down, everything is great, we're closer to our goals on this sprint and everything, but if suddenly it doesn't look right, we probably need to look elsewhere. And that's exactly the problem with those mega metrics. There are two cores. If everything is fine, we know what to do, we're happy and everything's good. When the profits go down, do we know what to do? Except of firing people? We are not sure, because we don't really know what the problem is. So this two cores thing also applies to DevOps. DevOps is also kind of two cores, because we just mixed everything together for the purpose of a keynote of a conference, but it's not really that. This is DevOps. Unless you are Netflix, and you're probably not. Anyone from Netflix here? Okay, yeah. So Netflix already hired all the unicorns that can do everything very, very good, and the rest of us are stuck with the rest of us that probably don't know how doing everything super good. So instead, we do have common goals, tools, and culture, but we still have this deep specialization. And our software engineers are great in writing software, and maybe less great in configuring Terraform and Kubernetes. And this is fine, as long as we have these common goals, tools, and culture, and we know how to collaborate and how to have this common communication going. The same with DevOps metrics. Instead of having one unified huge metric, we still have, which is still there of course, we still have those specialized metrics, those that I show you and others. And what's changing now is that we understand that they correlate to each other, they collaborate with each other, they influence each other. And I will give you a couple of examples of those metrics which actually influence each other, and you can see here that I have one that's who is affected by the metric of those. So basically, here's an example. Time to build, release pipeline stability, artifact replication topology, all those are actually influenced by ops. So JFrog, who knows JFrog? Artifactory. Okay, half of you. So it's, for the sake of the example, is a universal artifact repository. It has all your dependencies and artifacts and all the pipelines built on it and what's not. Now, who is the buyer? Who pays the money in their organization? Obviously, ops. This is their tool. They create the pipelines, and then the developers are using this pipeline when they ship their code to production. Now, if they didn't configure it well, dev will be affected, because their artifacts won't be there, their dependencies won't be there, the builds will failing, they won't be able to reproduce the builds, and all the other horrors that I tell you to convince you to buy Artifactory. Because remember profit? This. So it's a metric that influenced by ops, and it affects dev. Other examples, QA. Well, let's say QA keep opens false positives. It's something that affects dev as well, because now instead of writing code and shipping it and writing tests and what's not, they deal with false positives. The other way around. Here is how dev metric that influenced by dev affects ops. Let's say my code is not very resource aware. And now, instead of allocating a smaller machine for this pool of customers, because of the quality of my code, we have to allocate a larger machine. It will obviously rise the cost, the average cost of a customer, and that's something that ops dearly care about, but who actually did it was dev with their code. Knowing how those cooperate is actually DevOps. That's the cultural side of things. It's not necessarily means that now the ops have to know how to write effective code, or that the dev know how to configure Artifactory. It's just the awareness that there is someone in the same team that you are going to affect. Yeah, and then there are other examples. Smoke test quality, it's something that obviously ops with their release cadence will be affected if the QA fails, etc., etc. So there are a lot of examples. You can see them obviously on the slides on jfrog.com/show-notes. So that kind of the first part. What I wanted to say is, look how we take the same metrics, and just by the awareness that there are other people that work with you in this DevOps team actually get affected by what you're doing. Next, let's look at the metrics themselves. Let's start by categorizing which metrics exist and why are we doing what we are doing, why we are measuring what we are measuring. So the first is, are we doing the right thing? If we have a restaurant, why people go to our restaurant and not the restaurant next door? This is the first McDonald's in Moscow, opened in 1998. My sister is somewhere there in the cold for 2 hours waiting in line. Obviously, McDonald's did something right, versus the Soviet restaurant next door didn't do it. And there are a couple of things like good food, good service, the rest of it. Never mind. So the goal is we want to measure, is we doing the right thing? The other is continuous improvement. We want to cook better every time. So first time we have that, and probably 20 more times we have that, but eventually we don't have that. And that will be another reason why we measure. It's not necessarily are we doing the right thing, is what I'm doing today better than what I did last week? And the third type of measurement is building trust. Can I gather enough data so I can predict what is going to happen next? And people who are affected by my metrics, remember, the rest of the organization will have the trust in me that I'm doing the right thing. So since I started with all the cooking theme, finding a good illustration for trust in cooking was really hard. And I had this slide because I need to explain it, but it is what it is. It is actually the folks that tried the king's food to check that it's not poisoned. And look at the redundancy, right? It is highly available testing. Right. So for those types of metrics, we have different types of sampling. We sample differently if we want to measure different things. Remember the why. So for example, a complete sample. Complete sample is when you go to a grocery store and you buy 5 oranges, you will example all 5 of them. You don't want to examine one and then like, okay, this grocery store have good oranges, all the rest, it doesn't matter. You will examine all of them. And you do it mostly when you want to calculate your return on investment. So if you spend this amount of money to get certain feature to the market, you will take all the profits that you have, all the revenue that you have from this feature, and then you will assess, was it worth it or not? Did I do the right thing or I did not? Another example that I'm going to show you is done with an extremely complicated software dedicated for metrics. You will probably won't be able to master this software to the end of your lives, but I will show off because I know how to use it. It's called Microsoft Excel. Google Spreadsheet works, by the way, also. So here is an example of complete sample. What you see here is an effort allocation in a sprint that was supposed to work on the big feature A. And before we started collecting that, if people asked, that's by the way example from Leonid, and he is an engineering manager. And people came to Leonid and asked him, okay, how your team is doing? And he's like, oh, we're working on this feature A. And all the team is doing nothing else. And then they measure, and then big feature A is 30%. Why? Because there are obviously other things which are not less important, but if they didn't measure, they didn't know. Is 30% enough, not enough? Is it a lot? If it's not a lot, it doesn't matter. But now we know what we allocate our effort in. Another type of sample is representative sample. Representative sample is when you do, like, not all of it, but some of it. Okay, so here is a plate of cookies that, and that was actually meat with the meat thermometer, but then I thought about the vegans and the vegetarians and switched it to cookies. Yeah, thank you. I'm afraid you will take it back by the end of the talk, but yeah, sorry. Yeah, so you don't need to measure all the cookies on the plate. You can just measure a couple of them and get a good understanding on the temperature. So why are we doing that? This is for measuring our improvement. How effective are we? Are we better than we were last week? Samples are good enough for that. If we have most of the people reporting the causes or their bugs, we can have good understanding of the causes of the bugs without 100% sampling, as long as they are representative. If I only have the engineer that works on my delivery pipeline to report source of bugs, I will be under the impression that the only bugs I have in the continuous delivery pipeline, and everything else is perfect, which is obviously not the case. So they need to be a representative. And another thing, they need to be collected over time if we want to use the sampling for continuous improvement. If we want to understand, did I do better this week than I did last week, I need measurements from obviously both. The most complicated type of measuring of sampling is predicting the future, because for that, for building this trust, I need both. I need both as complete sample as possible, and I also need it over time. And this is complicated, this is costly, and not always possible, but this is what it takes if you want to build this trust. So now we're going to see some examples, and we will do it with Scrum Team Avengers, which is an extremely timely reference. Who already saw the end game? Oh, come on, people, what are you doing here? You really should be now in the movies, because it's amazing. Spoilers, no. But yeah, it is amazing. And yeah, so let's talk about Scrum Team Avengers. And what we will do here, we will take some anecdotes from their daily startups, and we will try to measure and see if they are even correct. And if they are, what can we do with data? So here's the first anecdote. We never get enough testing environments from ops, and we cannot improve the quality because we cannot test, because the testing environments are always busy. right? And you know, some of you will say, okay, that's not a good setup. All should be automatic, and you don't need a dedicated testing environments. Well, the reality might be different, and you might need some significant labs setting up with load and what's not. So let's gather data and see if that's right. And again, that's a real-world example. So here we have 10 environments, super expensive. This is only why we have only 10. And you can see that over time, they are really saturated, right? They're busy most of the time. So available is orange, and utilized is blue. They're right. No environments available. Next question will be why. And this why cannot be anecdotes, because we already agreed we cannot rely on what people are saying, because everybody lie, not because they're evil, but because they're human. So how about that? How about we measure how many days the environments stay checked out for each and every one of them? And then we see something that didn't come up on our stand-up meeting. Is it actually no one checks the environments back in? And you can see here that there are some very good people here, like Raj and Jane and Christina. Baruch is okay. Everybody after Baruch probably should be fired. Or we can just go ahead and implement automatic check-in. How about that? If you didn't touch it for 2 days, boom, it goes back to the pool. At first, while we're implementing it, we will provision some more environments. So we will go here to 12, and we will see how quickly and conveniently they are now immediately utilized 12 of them. But then, when we implement auto check-in, not only can we get the environments available, we can actually save a lot of money, 20% here, by doing this simple trick and still have more environments available. So by only measuring the cause and not relying on anecdotes only, we actually saved money and made the environments available. Here's another example. Tests are failing because the test suite is not stable. QA makes our build fail without reason. Valuable, very valuable feedback. Is it true? Maybe yes, maybe no. Maybe they just write shitty code and rationalize it with, well, but the build will fail, I won't even check why, because the environment is not good enough. What we can do? Data. So here's an example. This is Jira. It can be implemented with any ticket system or issue system, whatever. Custom issue type. Tested stability. We add it, and then we ask, okay, you know what? Let's see if that's right. Every time your build fails because the stability, open an issue. And we will see if that's true or not. And then we see something like that. Created versus resolved, one of the most useful charts on Jira dashboard. Well, hell yes. Look at that. We went to what, like 70, like 80 issues with the environment stability. Obviously, it's not stable. But also, we start fixing it because we know there is a problem and we have trust that this problem is real. Because before that, QA might say, you know what, you're a liar, so just write a shitty code and the environment is fine. But now, we actually have a proof that there is a problem, we allocate the resources to fix it, and in some point of time, it actually goes flat. I think there are like 3 issues that are open forever, just maybe because they're not critical or too expensive to fix, or there are workarounds, never mind. But it flats. It flats. No more new issues, and we are good. And that's again, just because we established this trust using data. No, they are not lying. There is a problem. Let's fix it. And the third example is something that again happened like in real life. Well, those developers, they went to some Java conference and they came back with the next big thing in Java. It's called new garbage collections. Shannon does something, whatever, doesn't matter. And just want to play with shiny new toys. So they want to replace all the JDKs in every environment. That's half a year of project, acceptance tests once not, and we don't really believe that it's going to change something, especially for us. And for us, it's like the ops side of the house. This is a problem of trust, and it can be solved with data. So we have those test environments. They're very production-like. This is why they're so expensive. And we can run the tests in them. So we can go and see what's going on if we start load. And you can see here that this new garbage collection actually does magic. Right? Comparing with what we have now, let's say we have G1. This is G1, and this is the new one. It is extremely efficient. And you know what they're thinking, the ops guys? They think like, whoa, we're going to save a lot of money. The cost for customers is going down because we need to provision much less hardware to achieve the same load. Yes, we want that. Can you please teach us how to switch the garbage collection in our environment? And they do. And this is actually what happens, right? So this is where they pull the switch, and boom, the GC pauses just disappear. True story, by the way. And again, they were completely against it before they gathered the data. So last part of our talks is a little bit of do's and don'ts, and just like general rules for any data measurement. Measuring the right thing. It's very easy to measure the wrong thing. So with software engineering, what is the most wrong thing to measure? Lines of code, obviously, of course. And this is very easy to measure, and it's very compelling because we have this shiny number, which can be compared and played with and rationalized about and what's not, but it's obviously a very wrong thing to measure. And the right thing to measure are usually more complicated than that, but sometimes it's the other way around. Sometimes we're so excited by this whole new data-driven life that we measure stuff that really no one cares about, and we only have it because it's fun to measure. Don't do that because data collection is important, is expensive, data analysis is expensive, data interpretation is expensive, and maybe you measure something that no one cares about. Maybe sometimes a simple food thermometer is enough and you don't need those other fancy things. I have no idea what that is and what it has to do with food. Why it's food? Yeah, no, but why it's here, I don't know. No, seriously, I have no idea. Okay. Reliable data. Obviously, when I gave you this example of this engineer that was the only one who reported their issue types, and we got a completely distorted picture. That's something that happens a lot. And I will advocate here for something which is, how do we call it, unpopular opinion now on Twitter that people hate so much. So unpopular opinion, no data and anecdotes are actually better than bad data. Because when there are anecdotes, we know how to treat them as anecdotes. You think my wife believed for a minute that it was 2 hours to completion most of the weekend? Of course she didn't, because she knows me. But if I came with numbers and there were wrong numbers, it does much more damage. So this is super important. Only the reliable numbers should be ever considered. A common vocabulary is extremely important, especially when we're talking about data. Stuff like severity of ticket types. Sorry about that. I apologize for the meat reference. I couldn't stay away. Yeah. Who declares that those issues are severity 1 or severity 2? How do we call escalations? Importance of features. What's not? There are tons of vocabulary that has to be put straight before we start putting numbers to those terms. Very, very important. And my favorite slide of this presentation is Dilbert. This is so good. Incentives, metrics generate incentives, incentives alter behavior, period. If we are measured by lines of code, we will write a lot of lines of code. If the QA is measured by the number of found and fixed bugs, there will be a lot of found and fixed bugs. So you need to remember every time that you come up with, whoa, that's such a great metric, let's start measuring that, don't forget to look at what it does for people's behavior, because there will probably be some adjustment. Sometimes it's good, sometimes it's okay, and sometimes, well, we cannot use this metric anymore because this. Remember the example with the test stability? It flattened in some point of time, and this is probably where we care less about it, because we had a problem, we fixed it, and now as the engineering manager, you don't need to come every morning to work and look at this dashboard anymore, because it's good. It goes with the cost of data analysis. Tweak as you go and change what you are looking at by what you are actually important to you at this point of time. And another slide that goes into costly data interpretation is what you look at. When you start collecting data, you start collecting tons of data. And you can look at the raw data, and that will give you some perspective. You will probably drown in it. Product-specific dashboard, you can build your Jira dashboard, you can build your Jenkins dashboard, and this is obviously a step up. But if you want to maximize your time spent with this data, it makes sense to look at the integrated dashboards. And here that's shameful plug, and this is shameless plug. And this is shameless plug. This is a screenshot of one of JFrog tools. It's called JFrog Mission Control, and that's part that's called JFrog Insights. It actually gathered information from different tools. You can see here commits that come from GitHub, build information that come from your CIs, Jenkins or whatever, the number of dependencies, build storage, that's from Artifactory obviously, average build promotions. I would say that's the most important metric, how many builds actually go to production or to your next environment, and average vulnerabilities count from X-ray. So if you come in the morning, instead of going to 5 different tools and checking the dashboards there, this might give you an example. There are obviously other alternatives. It happens to be that those people actually pay me, and the others do not. So going back to this, and this is what we are trying to fix. We are trying to come with the rest of the organization with better information than just anecdotes from the daily stand-up, because as my wife didn't buy the anecdote of 2 hours to completion, the rest of your organization don't buy your anecdotes of 80% radio 80% of the time. So instead, give them numbers. It removes the blame game. Now instead of, oh no, it's the developers, they write shitty code, this is why tests are failing, oh no, it's the QA, their environment is not steady, we can take a look and say, well, yes, the environment actually fails more builds than it should. Build accountability and trust. Well, this is why we say the release will be 2 weeks from now, not because anecdotes from daily stand-up. Create a common base from discussion. We can discuss this and that based on numbers. And for me, this is one of the most important parts of enabling DevOps in the organization. Because DevOps is about discussion. It's about communication. It's about giving people something to work with which is trustworthy. And this is what the data-driven life gives you. And with that, a lot of service stuff. I'm at JBaruch on Twitter. Now you are convinced, obviously. When you praise this talk on Twitter, use this hashtag because it comes on screens, and I'm like, look, Ma, I'm on the big screen. And data-driven DevOps, that's super official hashtag that I just came up with. So please use it as well. And JFrog.com/show notes, the slides, the video, the links, the ratings, the comments, the raffle, everything is there. And rate session in the app. Rate session in the app. Give it obviously 5 stars. Is it stars? No, it's like the green thing. So the 2 of others don't work. Trust me on that. That's a very reliable anecdote. Go with the green. And there is a price if you rate 5 sessions. So now after rating this one with green, you are 20% closer. If you like this and more of, there is more where this came from. JFrog annual user conference Swamp Up. It's all about DevOps. Is in San Francisco in June. And because I love you so much, 20% off if you go to jbaruch/GOTO Chicago. Come, it will be fun. I'll be there. And hopefully you'll be there as well. So with that, thank you very much. Questions? Have 4 minutes.